Hey everybody, Melissa here, coming at you from my very messy office at Salt Lake Community College to introduce you to our phylogeny lab. The first thing we're going to do as part of our phylogeny lab is look at some morphological characteristics and use them to build a phylogenetic tree. So I'm here with a few of my friends and we're going to demonstrate the morphological data that you would take. These are all mammal skulls, and I'll be walking you through the characteristics that we will be using to build our morphological phylogenetic tree. Once we're done with this, and it's important that you do the morphological tree first and submit that. Once we're done with this, you'll then construct a phylogenetic tree using the same organisms, but instead of using morphological traits, you'll be using molecular data, in other words, DNA sequences. All right, so let's get going with the morphological part of the lab. So first of all, what do I mean by morphological? A morphological trait essentially is a physical trait, okay? So we're gonna look really particularly at teeth, dentition, as we go through this lab, and some other characteristics that we can see on these beautiful mammal skulls. All right, so I have 10 skulls sitting in front of me, all mammal species. All of these are real bone, okay? So for example, this is a red fox, Vulpes vulpes, and it is the remains of a living red fox, okay? So this is all real bone except for my friend's the human skull, okay? So the Homo sapiens skull, this is a replica. We're not using a real human skull today. And also, my friend here, the chimpanzee, scientific name Pan troglodytes. Pan here is also a replica. All right, let's get started. Okay, so the first organism on our data table is this lovely organism, one of my personal favorites. This is the skull of a coyote, scientific name Canis latrans. So we're going to be measuring some of the morphological characters of the skull, and I'm going to show you first with the coyote because this is one of the easiest to see all the traits that we're talking about. All right, so looking at my data table, the first thing we're going to count is number of incisors. And for this, I'm actually going to remove the lower jaw and take it right off and put it down. And we'll be looking at the dentition. All right, so on the coyote, we can see that it's got some really lovely teeth, adaptations to its way of life, which of course is a combination of predation and scavenging. Okay, most notably, we have these really beautiful big canine teeth. Okay, you've got canine teeth as well, but obviously they're not as developed as this coyote's. We can also see back here the carnassial tooth. Okay. This is an adaptation that is common to members of order Carnivora, and it assists them in shearing flesh, essentially. Okay, so let's sort of orient ourselves to what kinds of teeth we have. In the front, we have the incisors, and then coming back, we have the canine teeth, and then behind the canine tooth, just like in you, we have molars and premolars. We're actually going to consider all these together as, quote, post-canine teeth, because in some species it can be quite difficult to distinguish between the premolar and the molar. All right, so we're going to start with the incisors. And as a general rule, when we do a dentary formula, we're only going to count half of the mouth, okay? So in the front, I can see that this coyote has 6 incisors. Okay, so 1, 2, 3, 4, 5, 6. But since we're only counting either the left or right half, doesn't matter which, I'm going to score 3. Okay, so I will write 3 incisors on my data table. The canine teeth, we do have one, so we'll mark that. Post-canine teeth, let's see, I count 1, 2, 3, 4, 5, 6. And if we kind of zoom in a little bit more closely, you can see past the canine, 6 post-canine teeth on one side. So I'll put that in my data table as well. All right, we might notice as we start looking at the skull that there are lots of little holes kind of all over the place. And these holes are referred to as foramina, that's the plural, foramen being the singular, and they're to allow the blood vessels as well as the nerves to come through. So we're going to be looking at the incisive foramina. These in the coyote are two fairly large holes right here on the top part of the palate, right behind the incisors. So I'm going to count the number of incisive foramina, and the number on the coyote is going to be 2. Okay, next, let's look at the sagittal crest. Okay, so we're going to now be looking at the top part of the skull, and you can see as we follow the midline down the skull, okay, right on the midline, we have this lovely crest that stands up. This is the sagittal crest. We're going to score these skulls for presence or absence of a sagittal crest. The sagittal crest, by the way, is where the temporalis muscle attaches, okay? It kind of goes through these zygomatic arches and provides some of the bite strength for the organism. Your temporalis does not attach, by the way, to a sagittal crest. It attaches right about here, and if you touch your temple and then chew, you can actually feel the muscle attachment of the temporalis. Okay, so we're gonna score a 1 for the sagittal crest. And then we also are going to look at the orbit, okay? So the orbit is essentially the eye socket, so where the eye is going to be placed on the skull. And if we look at the coyote, the trait that we're going to assay is the orbit closed or is it open? Okay, so this is the orbit right here, and we're going to call it open because it opens up back here to this space behind, okay? It's not a complete circle of bone. Here's the dorsal view of the skull, here's the side view, and you can see that that orbit is not a perfect circle. Okay, so we're gonna score that orbit closed, no, so we're gonna give that a 0.